Paleoceanographic tool.
Hello, my name is Savannah Myers, and the title of my thesis is Planktic Foraminifers to Reconstruct the Eastern Mediterranean Sea Paleoceanography at the time of Sapropel S6 deposition, approximately 176,000 years before present. My supervisor was Alessandra Negri of UniVPM, located in Ancona, Italy. So sapropels are dark-colored organic-rich sediment layers, and in order to be considered a sapropel, the sediment must contain more than 1 to 2% organic carbon. And the first observed sapropel is from the Middle Miocene, being about 14 million years old. Sapropels are interesting because they demonstrate that in the Mediterranean Sea, there was periodically widespread anoxia. And so the topic of sapropel formation is widely discussed and unresolved, but increased freshwater influx is a main factor. And some examples of freshwater influx into the Mediterranean Sea during this time period would be the melting of glaciers from the southern European continent and increased Nile River discharge caused by the African monsoonal system. And so this freshwater influx would cause density-driven stratification in the water column, productivity in the water column, and anoxia in the bottom waters. This will then cause reduced deep water ventilation. And overall, these factors are influenced by astronomical cycles, like, for example, the precession of the Earth. And astronomical cycles are also responsible for the glacial and interglacial climate cycles as seen throughout Earth's history. And so here, the dark black line represents temperature and shows some of the glacial and interglacial periods throughout time. And the object of this study, which is Sapropel S6, is shown here to be in a glacial period. So a tool used to unravel this enigma of sapropel formation could be planktic foraminifers, which are eukaryotic unicellular microorganisms with calcareous shells. When they die, they sink to the bottom and become buried within the sediments. And so by studying the ecology of each species, they can be used as a proxy for the oceanographic and climatic conditions for the time that they were living, thus making them great indicators of global climate changes. So the aims of this research was to discover the mechanisms behind Sapropel S6 deposition, so to really understand what triggered the formation of this sapropel layer, to reconstruct the oceanography and environmental climatic conditions during Sapropel S6 time period. And all of this will help us to understand how Earth responds to climate changes. So the S6 foraminifer samples for this study are from a deep sea sediment core taken from the Ionian Sea in 1993. The water depth at this site was about 2,500 meters. And so here's an illustration of the core, which contains Sapropel S1, the youngest sapropel, all the way through Sapropel S10. And here lies Sapropel S6. So the core was broken up into 13 100 centimeter sections, where Sapropel S6 is present in section 9. And S6 is broken up into 3 parts caused by interruptions, which are caused by reoxygenation events to the bottom waters. And the base of S6 contains 2 volcanic ash layers. So in order to understand what was happening before, during, and after S6, we decided to collect 62 samples starting from section 881 starting from centimeter 881 in section 9 and all the way up to centimeter 700 in section 8. The sediment was dried, washed, and sieved in order to gain the foraminifer content. So I then fractionated each sample, and for each sample, I identified 300 specimens up to the species level and counted how many individuals were in each species group. I then glued each specimen to this cardboard plate and recorded the data. And so throughout all this samples, I was able to identify 28 different foraminifer species. And so using the count data, I was able to calculate the concentration and percentage of each species throughout each sample. And these values were plotted against the core depth in order to obtain a curve that represents the trend of each species throughout the sapropel. And so this is an example of a high nutrients indicating species. And so each species of planktic foraminifers has their own ecological requirements. And so based on the recognized trends, we can interpret what different conditions were like throughout the sapropel. And so I was able to sum up the species that prefer warm conditions, the species that prefer cold conditions, and the species that prefer high nutrients, each into their own respective profiles. And so by doing this, you can easily see that, for example, here at this time period was a very cold and period. And then here you can see that there was a slight cooling trend by noticing the decreasing values of cold species. And so this study followed a multi-proxy approach, meaning that I was able to compare proxies from from previously produced data and compare them to my foraminifer data. And so this gave me more data to interpret, which is helpful to detail what is going on throughout Sapropel S6. So one of these proxies was oxygen stable isotopes, where this told me information about the temperatures in the deeper waters and also in the surface waters. And I also looked at calcareous nanofossils, where each species or group of species indicates a specific condition. So for example, Coccolithus pelagicus is a cold indicating species. And so here we can infer that this was a cold time period. I also looked at dinocyst data, where I summed up the cold indicating species, the productive indicating species, and this genus represented stratification, and this genus indicated low nutrients. So lastly, I looked at pollen data, where I grouped the different pollen types into trees and herbs, where trees indicated warm conditions and herbs indicated cold conditions. So by closely comparing all of these proxies, I was able to come up with some conclusions about what was going on during the time period of S6. So before the Sapropel, the conditions were shown to be quite cold, and this goes along with the fact that this is a glacial period. And directly before the Sapropel, the conditions were very cold and very productive. And from this, we can infer that there was probably an increased freshwater influx caused by the melting of glaciers from the southern European continent. This would then cause stratification in the water column, preconditioning the water column for ideal sapropel forming conditions. And so at the base of the sapropel, the conditions were warmer and highly productive, and there was an indication of a deep chlorophyll maximum. And so from this, we can infer that there was probably an enhancement of stratification caused by increased Nile River discharge due to the African monsoonal precipitation events. And so this study can then hypothesize that these two sources of freshwater influx were the main triggers behind the formation of Sapropel S6. And we can also say that because the glacial meltwater is coming from higher latitudes and the Nile River discharge is coming from lower latitudes, we can say that the formation of Sapropel S6 was influenced by the interplay of two different climatic latitudes. And so in the last half of the Sapropel, there was shown to be a slight cooling trend and less productivity than before. And from this, we can infer that there was probably a decline in the African monsoonal system, and which would destabilize the stratification in the water column. And this matches up with the fact that there are two interruptions during this time, which are caused by reoxygenation, which was then caused by the destabilization of the stratification. And so this study also it hypothesizes that interruption 2 was specifically caused by a turbidity current, which would bring lots of oxygen to the bottom water. And we know this by looking at the physical sediment core, because the texture of the sediment during this time was very erosive. And so throughout section 8, the temperature or the conditions were quite cold and highly productive. And this also goes along with the fact that this was a glacial period. And so overall, this study agrees that yes, Sapropel S6 was during a glacial period, but during the actual Sapropel, the conditions were actually more mild rather than being strictly cold. And so another thing to point out is that it has been found that Sapropel formation is connected with increased CO2 levels in the atmosphere. And so by knowing this, and by knowing a little bit about how sapropels are formed, this study hypothesizes that in the foreseeable future, there will most likely be a new sapropel being formed, Sapropel S0. And we can say this by looking at the current climate situation that we are in, which is defined by increased CO2 levels, increased temperatures, melting of ice, and the increased amount of extreme precipitation events. And so the study of sapropels and paleoceanography is very important for climate science, because by learning the lessons from the past, we can better understand what is happening in the future, and then, or better understand what is happening in the present, and then try to predict what will happen in the future. And that's the end of my presentation. Thank you very much.